Today we're solving right triangles. Now you might be asking yourself, haven't we been playing with right triangles all along? Yes, we've been playing with right triangles all along. But what makes this different is, whereas before we were saying, hey, get that angle, or hey, get that side, today it's like, hey, get everything. Everything that's missing. So in doing that, of course, we're going to use SOH CAH TOA a lot, right? But that's only one of our tools. It's an important one. It's a huge one, but it's only one. SOH CAH TOA. So knowing your SOH CAH TOA definitely helps. But it's only one tool, and actually we usually only use it once. You only have to use it once. You could, if you want, SOH CAH TOA all day long and solve for all the information, but there's other things you can use. Don't forget the other things. This can make your life a little quicker. Don't forget the Pythagorean Theorem. I know you know it. I know you've heard of it. The Pythagorean Theorem comes in handy. You don't have to set up any opposite adjacent. You just do the old a squared plus b squared equals c squared. What a nice formula, right? Now, there's one terribly important thing about this formula. I see people occasionally slip on this. You have to be putting the hypotenuse on the right. That has to be the hypotenuse. In fact, I'm going to change to a red color, and I'm going to say, hey, okay. It has to be on the right. The hypotenuse has to go there. If you put the hypotenuse as an A or a B and you put it on the left, the equation's not going to work. The formula just won't work. So just make sure you always have the hypotenuse on the right. The other tool that comes in handy, and this is a heck of a shortcut compared to SOH CAH TOA, is got to do with angles. You remember something about triangles and angles, right? The angles always add to 180. Well, I'm going to state that a little differently, because for a right triangle, when you know one of the angles is 90, and they're all 180, well, that means the other two have to be 90 as well. So the two acute angles, not the 90, but the two acute angles, the sharp angles, the angles that are less than 90, must add to 90. Now I want to emphasize, so I will. For right triangles, we're talking about solving right triangles. So you can use these things on right triangles. SOH CAH TOA, if it's a right triangle, feel free. If it's not a right triangle, don't be doing any SOH CAH TOA stuff. It doesn't apply. If it's a right triangle, go ahead and do Pythag. If it's not a right triangle, don't do Pythag. It doesn't apply. And then this angle, of course, assumes that you had a 90 in the first place. So make sure this is for right triangles. Hey, I know. We'll put another one of those red exclamation points. Okay, cool. But we're playing with right triangles today, so here's one. Looks like I circled that for some reason. Let's uncircle it. Okay, so two sides are known. Yeah, I should say there's two basic situations that we're going to face when we're solving right triangles. Either we'll know two of the sides, like this one and this one, or the other situation is we'll know one of the sides, but also one of the acute angles. Those are the two situations we face. So I got, I think, two examples of each. Yep. Two examples of each. So let's do it. So this one, well, what do you want to solve for, an angle or a side? I don't see any angles. I want to get an angle. So I'm just going to, I don't know, you could call this anything you want. Maybe I'll use the theta again, the Greek letter theta, and I'll say, okay, I just picked that angle arbitrarily. I could have picked this one, but I just didn't. So I'm going to pick this angle, and I'm going to say, let's do SOH CAH TOA to get this. So I always know that's the opposite because it's way over there. So this must be the adjacent. This must be the hypotenuse. And so we've got a cosine situation. The cosine theta is the adjacent over the hypotenuse. And remember, when you're solving for theta, you're going to have to do shift cosine. And anyone that's taken college algebra will recognize this as we're doing an inverse function. Some people call this the inverse cosine. Some people call this the arc cosine. You know what I call it? I call it the shift cosine. Remember to get the F in there. Shift cosine of, and you just put those numbers in. Shift cosine, here we go. Come on, you, where are you? Here it is. Shift cosine of 18.7 divided by the 23.1. Boom-o. 35. And rounding to one decimal place is good for angles. So it's 35.95. So I'm actually going to round it to 36.0 degrees. That's cool. And then while I've got the 35.95 blah, 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 on my calculator, I can just go like this right now, minus 90. And it gives me a negative answer, of course, but I know that it's 54. It says negative 54 because I subtracted 90 because I was too lazy to start typing this again. I didn't want to have to keep typing. So I just, whatever. It's my shortcut. Follow it if you want. The main point is these two angles. Hey, what's going on here? Okay, these two angles have to add to 90. So 36 plus what is 90? 36 plus 54 is 90. Look at that. We got the two angles. We're only missing one piece of information now. Isn't this fun? Just one, and it's this one. And am I going to set up SOH CAH TOA for this? I could. I don't have to, because I can Pythag it. I'm going to Pythag it right now. So let's see now here. Remember to put the hypotenuse on the right side. So I should have like my x squared. These are called legs, by the way. So my two legs. Square them and add them. X is squared. 18.7 is squared. And when you square them and then add them, you get the hypotenuse squared. So if you wanted to solve this for x, first thing you would do is you would subtract the 18.7 squared on both sides, right? Do that first, and then you'll have x squared equals, and then you'll have to take the square root to just get an x. So x is the square root of that stuff. So I'm going to just type that in right now. Square root of that stuff, 23.1 being squared minus 18.7 being squared is, and I'm getting 13.56. You'll see me use 4 sig figs a lot for my answer. Remember, this counts as the first one, so 1, 2, 3, 4. That's 4 sig figs. Doesn't mean 4 decimal places. It's different. It's 4 sig figs, 4 measured numbers, you might think of it. Anyway, I'm going to use 4 sig figs a lot. In this case, it's kind of a nice choice because, look, they've got 3, they've got 3. You want to give them one more. Just give them one more. So they say, well, that's not really 13.5. It's not really 13.6. It's more like between. It's 13.56. Pardon me. Okay, but anyway, you get the idea. I had to use my my SOH CAH TOA to get one of the angles. And then after that, I didn't really need SOH CAH TOA anymore. I just used Pythag, and I knew the angles added to 90. The two cute ones did. The cute ones. The cute ones. All right, come on, back to blue. So this triangle's kind of similar. You could pause and try it yourself if you want. Just make sure you get the same answers as me. So I got these two angles that are unknown. I got to solve for one of them. Doesn't matter which one. I'm just going to stick the theta there. Not sure why. I just did. So let's see. What do I got here? This would be the opposite. That's the hypotenuse. So this is the adjacent. Opposite adjacent is tangent, right? So the tangent of theta is 98.7 over 46.3. That's a 6. Oh, man. I want them to make sharper. What are you doing? I want them to make sharper Apple pencils. Why can't they make sharper tips on these things? Come on, make a sharper tip. So anyway, 46.3. Okay, so remember, it's the tangent of, you plug theta in. You don't plug these numbers into tangent. So to get theta out, you have to do a shift tangent, otherwise known as tangent to the negative 1. It's not a power, but tangent minus 1 notation, I guess. And just stick those numbers in there. So shift tangent. Come on, you. Shift tangent. Let's wake up, calculator. 98.7. Divide that by the 46.3. Hit the old equals button. I got a, and again, angles I round to 1 decimal place. So this is like 64.9 degrees. Answer. Cool. Now I could go 90 minus that, or if I'm lazy, I can go minus 90 and it'll be negative, but I'll take the negative off. So this is 25.1. Bada boom, bada bing. We're rolling right along. And then, oh, this is the nice Pythag, right? Because we're solving for the hypotenuse. So you just do the old 98.7 squared plus the 46.3 squared equals the hypotenuse squared. So take the square root of all that, right? So square root of. Now, make sure you square them, add them, and then take the square root. The last thing you do is a square root. If you take a shortcut, you'll get bad answers. So anyway, 98.7 is being squared, and 46.3 is being squared. They're added together. I can hit equals, and then I can hit the square root button of answer, and then I'll get, what do I got here? 109, and if I go to 4 sig figs, 109.0. Come on, you Apple Pencil. 109.0. Cool, so that's the basic situation. When you have two sides, you're going to SOH CAH TOA to get an angle, and then you don't need SOH CAH TOA after that. You can use Pythag. You can say the angle's at 90. Pretty cool. All right, here's the other situation you'll face. This time we know one of the angles, but we only know one of the sides. Well, how about we just get this angle right away? So 90 take away 41, what is that, 49? I hope I'm doing that right. I always have to check. 49 plus 41 is 90. Right. So I got the other angle. Woohoo, we're cranking. Problem is we don't know any of these sides. So you're going to have to pick a side and solve for it. I picked this side. It doesn't matter which side you pick. What matters is that once you pick a side, you get the right trig function. So remember, you have to decide which angle am I going to use right now, because that makes the opposite and the adjacent switch places depending which angle you use. So I'm going to use this angle. So if I use this angle, that would be called the sine. When you go opposite over hypotenuse, that's a sine, and that's opposite over hypotenuse. So what do I got here? I got the sine of 41 degrees. Yes, take the opposite over the hypotenuse, and this is the nice case because all you got to do is multiply both sides by 28 because it cancels. So x is 28 times sine of 41. Boom, 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 boom. Boy, this is so much nicer than slide rules, ain't it? So you got 18 point and to 1 decimal. No, this is a side, so I'm going to do four of these. Actually, you know what? It says, this is what it says, 36965, blah, 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 blah. Now, if this were a final answer I were reporting, I would use 4 sig figs, and I would say 18.37 is my x. So maybe I'll write that in a different color just to distinguish the answer. That's an 18.37. But if I'm going to make a calculation with this thing, I'm going to keep 5 sig figs. So for calculation purpose, if I go to 5 sig figs, I'd have to take the 6 says round that up. Wow, that's interesting. It ends up making no difference. Okay, but anyway, I usually use 5 sig figs when I'm plugging it into the calculator, 4 sig figs if I'm writing down the answer. It's just a habit. So anyway, we're trying to Pythag, aren't we? Yeah, we want to solve for this side. Maybe I'll call it like y. So we got the old leg squared plus leg squared. Actually, I know what x is. I just solved for it. Come on. So I got the 18.37. That gets squared. Plus the other leg is y. That gets squared. And these add up to, remember, this is the important thing, always put your hypotenuse on the right. Hypotenuse on the right. With a red exclamation point. Okay. So to solve that one, after a while you start to be able to do these things in your head. You just say, well, here's my y squared. So on the other side of the equation is the 28 squared, and I'm going to have to subtract this 18.37 squared on both sides to get it out of the way, sort of, get it away from the y. And then what I'll have to do is take the square root of both sides. So just make sure you're first squaring this and subtracting them, and then the square root is the last thing you do. Because obviously if you take the square root now, you're going to take, if you take the square root of these things separately, you go 28 minus 18.37, you get something a little less than 10, which is not going to be the answer. Here's the answer. No. Okay, here's the answer. 28 squared minus 18.37 squared. Hit my equals, hit my square root of answer key, boom, and what I'm actually getting is nothing like 10. I'm getting 21 I'm reporting this, so I'll call it 21.13. So there's my answer for that side, 21.13. Did I already solve this triangle? Boy, that didn't take so long, huh? So even though it sounds like more work, find everything, it really doesn't take that much longer. So what did we just do? We had an angle, so we did a Pythag to get one of the sides, right? You can't use Pythag if all you know is one side. Pythag, you have to know 2 things in order to get anywhere, right? So if you only know one side, you know you can't do Pythag yet. You're going to have to SOH CAH TOA to get one of the missing sides. And once you do, you can Pythag, and then the angle is the easy part in this case. All right, run more. Maybe you want to try this yourself. I don't know. You can pause. You can come back and see if your answers match. First of all, I'm just going to do the old 90 take away 28.2 trick. 90 take away 28.2 trick. 61.8 degrees. I'll put that in a different color. So this is a, come on you, 61.8 degree angle. Sure that decimal's there. We got one of our three answers, just like that. All right, now, not going to get anywhere with Pythag, are we? We only have one thing to plug in. You need two things to plug in. Not going to get anywhere with Pythag. I like Pythag. I love it. But you need two sides. So we're going to have to solve for one of these two missing sides, and it doesn't matter which one. Maybe I'll solve for the hypotenuse, just because. So let's see, what would this be? What would, if I went like this across the triangle, right? Remember, this is my point of view. This is where I put my eyeballs, so to speak. So from here, if I walked across to the triangle to the opposite side, that would be the opposite. That would be the hypotenuse. We're talking about a sine here. So the sine of that 28.2 degrees is equal to, you put the opposite side over the hypotenuse side, which is x. Now this is one of those situations. X is on the bottom, and you might remember my shortcut. My shortcut is that these two things can just switch places like this. You're multiplying on the diagonal. So you end up with x is equal to 89.4 being divided by the sine of 28.2. Now, hopefully you're not, there's nothing mysterious there about swapping places. I mean, you could think of this as like a, well, you could think of this as like a proportion if you put that over 1, right? So the cross products must be equal. So you have x multiplying the sine of 28.2, and that equals 1 times 89.4. And then look what you have to do. You have to divide both sides by that sine of 28.2. So this is being divided by the sine of 28.2, which is what I said over here. So you can do it the longer way if that makes you feel safer, which sometimes that's how I used to fly. I used to say, okay, I know there's a shortcut, but let me just do it this way for a while. And then after you've done it that way for a while, you too will say, yeah, I'm going to use the shortcut. Anywho, we're going to take the 89.4, and we're going to divide it by the sine of 28.2. Boom. And what I'm getting here on my calculator screen is I'm getting something like 189.1860, whatever. That's a lot, right? So what am I going to report up here? So at this point, I think I'd like to officially state if this rounding rule that I've been following. This is what they taught me back in the day. Rounding rule for tech calculations. And it kind of is a nice way of making sure we all kind of get the same answers. That would be nice, right, if we all kind of got the same answers. So rounding rule for tech calcs. The first part is you carry 5 sig figs throughout your calculation. And I try to make this a habit. I may slip at times, but carry 5 sig figs throughout the calculation. If you're calculating something, if you're chugging numbers, then use 5 sig figs. Report 3. If you're getting ready to circle your answer and turn it in, round it back to 3 sig figs, circle that, turn it in. Okay. Now I cheat a little bit. This is a personal preference. Nobody taught me this. Personal preference. If they give you 3 to start, in other words, you're not just measuring data or something. If they give you 3 to start, I like to report 4. And it's because I don't like rounding things off, especially when you're rounding like a half up to 1. To me, that's like, that's I don't know. I get nervous rounding things like, what does this say? Oh, I like, that's what that says. I like, or I prefer to report 4. Okay, so in other words, looking at this problem, usually you'd round your answer back to 3. So in other words, we would report 189. But because I'm me, I like to follow my own preference and say, no, they started with me with 3. I'm gonna report 1 more. And so I'm looking at the 4th. So that's 1, 2, 3, here's the 4th. So because of that 8, I should really be rounding this up to a 189.2, and that's what I will report personally. By the way, angles, 1 decimal place is good enough for angles for our purposes. If you really want to be accurate, maybe go with 2 decimal places. But angles don't really follow sig figs so much. In other words, I'd go 1.1 degree and call that good, and I'd go 199.1 degree and call that good. It looks like only 2 sig figs and only 4 sig and 4 sig figs here, but I don't think that's really true. So with decimal places, I just kind of 1 decimal place, maybe 2. Anyway, 189.2. So we're not quite finished with this problem because we still got to get that other side, right? So I'll switch to purple now. We need to solve for that side, which is a leg of this triangle. We can use a Pythagorean theorem to finish off. No need to use SOH CAH TOA twice in a row. So good old Pythagorean theorem, a squared plus b squared equals c squared, right? And the important thing, make sure you're putting the hypotenuse on this side. So that's a leg, that's the hypotenuse. So I've got an 89.4. That's as accurate as they gave it to me. That's all I can do is put in an 89.4 squared plus a y squared equals. Now this c, that's a number I calculated, and I can do better than 189.2, and I will. I'm going to go to 5 sig figs because I'm using it in a calculation. Get it? I'm in the middle of crunching numbers. So I'm going out to the 8, and actually because the 6 is telling me to round up, I'm going to use up 189.19 squared. So I'm just illustrating good hygiene. This is good calculation hygiene. So, okay, time to finish this up then. So grabbing up my calculator, 189.19, hit the square button, minus 89.4, hit the square button, hit the equals button, and I've got this 27,800 or so. So what did I just do? I just took the 89.4 squared and subtracted it from both sides, and I actually punched the numbers. I'm looking at a 27,800-ish on my calculator, but the point is, what do I have to do now? I have to take the square root of both sides. So now I just hit the square root of the answer button. Boom. 166 point to 5 sig figs, it would be 7.3. The 3 is followed by a 4, so to 5 sig figs, it would be 166.73. In my report, I'm going to put 166.7. And there we go. We have solved that right triangle. We found all the missing information. And by the way, one way to spot check at the end that things are at least not terribly wrong, take a look at your 3 numbers and make sure that the hypotenuse is the biggest side. Right? If the hypotenuse is not the biggest side, then you know you've got a problem. You've got to go back. But the 189 is the biggest of my sides. It is the hypotenuse. We're good. Okay, solving right triangles. It's what's for dinner.